Morning, everyone who's just joined us from one of the other tracks. And for those of you who are continuing through the education track, we're going to start our next presentation. This presentation is from Dave Bracken, who's the Senior Lecturer in the Department of Computing at ARA, which is formerly the Christchurch Polytech in New Zealand. He is a maker, coder, networker and educator, and he's going to be giving us a rundown of his Python course, which is being used by 2 academic providers in New Zealand and uses CodeRunner for marking lab work and assessments. So for Automagically marking Python coursework and assessments in seconds, it's over to you, Dave.
Thank you. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Welcome to this morning's session, folks. This is Automagically marking Python course and assessment in seconds. It should actually be milliseconds, but let's see what we can do in reducing this. So about me, I'm Dave Bracken. I'm originally from Manchester. I call New Zealand my home, and I have done for quite a while now. I've been at Christchurch Polytechnic, or as it is now, our institute, for just over 7 years. I'm a long-time computing person, to be honest. The only thing I've ever done in my entire life is work in computing. I did 23 years in industry doing network support, programming a long time ago, and most recently sales, pre-sales technical support as well. So I'm now at our institute. We just recently renamed in terms of the department, now with the Department of Digital Innovation. And there was a released from the government yesterday, so we're going through a process of amalgamating polytechnics in New Zealand. So we're about to become effectively one national polytechnic. So there's going to be more news on that next semester. So in terms of names, apologies for the different names that are out there, but we're going through a process at the moment. So my subjects that I currently teach are programming and a level 5 diploma, and the initial part of the programming section for our level 7 postgrad diploma at the Signal Graduate School, which is just around the corner from us in Christchurch. I teach Cisco Networking, and I must admit it's the networking side of life that has recently changed as far as Cisco is concerned, because they've changed track from what used to be infrastructure support to effectively saying networking is now writing code, and predominantly Cisco is saying it's Python that's at the front of that, and that's absolutely a superb message to receive from Cisco a few months ago. I've also taught Microsoft infrastructure support as various programs, and most recently cybersecurity, and no doubt there will be others as well. So computing at ARA, one of the things that I really want to focus on today is that obviously we offer our own courses and we offer those courses to other providers as well. But we also work with ICT teachers in the local schools. Now I remember Ben from his first presentation here asked how many people were teachers, and from memory there was quite a few teachers present inside the room. That's really good to see. So one of the services that we offer is that we work with local teachers to upskill them to deliver ICT subjects to their students. We also have a really well-provisioned computing setup inside the Polytechnic provided by corporate IT and also by the staff inside the Department of Computing, where we have our own 4 specialized networking rooms, and we also have our own infrastructure there, and it's that infrastructure there that's hosting some of the services that you're going to see. So we have a really close working relationship with IT, which is absolutely brilliant, but I can appreciate, and I've heard stories from lots of other staff, that they've tried to do things inside their own environments only to be told by either their IT support people or their IT provider that they can't do this and they can't do that and they can't do something else. So in that case, we at Tara are really fortunate in that we can do lots of things purely because we work so well with our IT team. So much so that we've got our own rooms with our own separate networks and our own separate infrastructure as well. So the background to automation, as I said, I've worked in computing for 20 plus years and must admit almost everything that I looked at, the first thing I'd say is, how can I automate this so much so that I don't have to do it again? Regardless of the language, I've used lots of different languages and lots of different solutions. And I took the same approach when I was asked to write a new programming course for ARA, that was going to be introduced for our networking diploma. In that I said, how do I automate this so much so that I can actually see what the students are going to do? And my first thought was that the students were going to upload their code, and I was going to magically download their code, and I was going to magically execute their code, and I was going to magically submit data to it, and I was going to magically receive feedback for it. There's an awful lot of magic there. And then I saw a product called CodeRunner that was created by a member of staff at the University of Canterbury, who effectively did all of this magic for us. So I started to apply the products I created, which are both called CodeRunner and Job Engine, to my programming environment. So the programming course that I actually created is a typical programming course that no doubt we've all got variations of the same thing. We've got conditional statements, we look at objects, we look at methods, we create functions, we look at the designer test data, and I remember also Ben saying earlier on that it's quite difficult to create a course that actually encompasses all of our learners because, and especially in my case, some of the students who come to my class have actually got prior programming experience. Some of them got quite a few years of prior programming experience. Some of them have got absolutely no programming experience. So actually presenting a course that keeps all of those people happy is quite a big ask. So much so, at the end of my course, maybe about 3/4 of the way through it, I offer an option to say you can go and create, well, I'm suggesting Flask, it could be any web development framework there, but you can go and create solutions just using this. So use all of the tools and techniques that you've seen throughout the course, and then go and do bigger and better things. So it's quite flexible in that case. So as I said, I approached this initially with how do I facilitate, how do I create a course where I can see what the students are doing? Now, sorry, just quick hands up, how many people use Moodle? Moodle, quite a few, that's good. So we all know about the interface, we all know that we can create quizzes of various types, we all know that when we go in there, and this is recent data, we can go in there so we can see what the students are actually doing, and sometimes in real time. And so for those questions there, they were taken out of one of my early labs that I've got inside my programming course. I could actually drill down, and I'm not going to do it for real time because I actually show the student information, but I could drill down inside there and then actually see the code that the student has uploaded, and then I can see what test data has been applied to their code, which actually results in them getting the scores that they're seeing. So this is my take on, this is how I see what the students are doing. And I actually award marks for the students for doing every single lab that have got a part of my course, and that's the initiator for the students actually want to go through my lab work. So I get to see what the students are doing, just as it would if it's a quiz. You decide on the type of quiz that can be applied in Moodle, but the difference is behind that is the actual student code that they've uploaded, that Moodle has actually tested and actually given a mark for this. As I said, I didn't create this, I'm just a user. I'm a really enthusiastic user of this. It was created by a guy called Richard Lobb from the University of Canterbury. I just want to say thank you very much to Richard, because if it wasn't for Richard creating this, I'd still be marking stuff from last year and trying to give feedback. I actually downloaded all of the code last year that the students submitted in one semester, and I think there was close to 120,000 lines of code. And that's the point where you think if a teacher is roughly 30 years old, after trying to give feedback on 120,000 lines of code, they're going to look 50 by the end of the week. It's not something that scales. So what we need is an automated system that takes a student code, executes it, gives them feedback, allows me to track it, gives them marks, and we can all see where they are. So thank you very much, Richard, for actually creating CodeRunner and Job Engine in the first place. So the development process that the students go through is a typical development process. I've heard folks talk about using Pseudocode. I also use Pseudocode. There's lots of design frameworks that we could be using. I'm quite happy using Pseudocode just to get the students into the initial idea of breaking a problem down into individual tasks so that they can take that and then apply it to a programmatic solution using Python. So the emphasis here is that they develop the code on the desktop and that they test their code on the desktop. I give them ideas about how they can test the code. I remember seeing examples earlier on about looking at boundaries from one of Ben's presentations. I've got pretty much the same tests, so less than 50, greater than 50, greater than or equal to 50, those types of things. So I'll explain some of the test data that I'll use, and I'll actually give some of the test data that I use to the students as well, but not all of the test data. So the students are sat there, you might think, oh, Dave, come on, that's not fair. But I really want the students to think outside the box about how they can test their own code. So I give them some of the test data, and they develop their code inside the IDE. I must admit, I'm IDE agnostic. All of the demonstrations I give as part of my course is done using IDLE, but I encourage students to use whatever it is IDE that they prefer, that they feel comfortable with. So once they've done their testing, once they say that their code is good, it actually is a good solution to the problem, then they take their working code, emphasis on working code, for if any of my students are going to be listening to this later, not code that didn't work in the hope that magically when they submit it to Moodle it will work, but they take their working solution, send it to Moodle, Moodle takes their code along with all of my test data, packages it, sends it off to a virtual machine which executes it, which sends it back and then says to the student yes or no. It either passed all of the tests or it passed the individual tests. And all that happens, and we can do it in a few seconds, hopefully if the demo folks are looking down on us, we can do this, sending it from here to Hamilton, the North Island, New Zealand, then from Hamilton back to virtual machine Christchurch, back to Hamilton, back to Sydney in probably less than a second, I hope. But let's see how that pans out in real time. So the students can run through a lab wherever they want. Obviously, they have to turn up. We do track attendance. But outside of class time, which is actually quite significant, they can work through the labs at their own pace, and I most certainly encourage that to happen. So the internals of both CodeRunner and Job Engine. CodeRunner is the plugin that goes into Moodle, and then Job Engine is a separate system which actually executes the code. And Rich has described two different ways of having this set up. You can either have it run just on the Moodle server, although it's possibly not the best approach, or you separate this into two separate services. You have your Moodle server, and then you have your job execution engine or your job engine on another server, ideally another virtual machine, because that gives you the flexibility to use this. So we create the questions in Moodle, just as we created questions in Moodle for a long time. We give it the test data, and then the job engine packages all of this together, sends it over to the job engine for execution, which does, and then it sends the results back, which goes through a grading system, which eventually gives the students the mark. This is what it should look like. So this is a server rack we've got, so it's actually just around the corner from my office, which hosts some of the job engine virtual machines there. But I've got to be honest and say none of those are actually in production use, and none of them have actually been used now for several months. So the specs of the machines, the specs of the virtual machines is that one's got 4 cores and I think 8 gig of RAM, and to be honest, it just sits there most of the times, even when it was in use, just twiddling its thumbs, purely because the actual load on the server is not that great. I said to be honest because that's what it's actually running on now for the last 8 months, and that's the PC underneath my desk. And I did that intentionally because I eventually wanted to be in this position where people said, yeah, but I can't afford a server, and IT won't give me this, and we don't have the budget, and I don't have a credit card to go to a cloud provider. I'll say, you've got a PC. Can you install a hypervisor on it? Can you install or enable Hyper-V? Can you use VMware Workstation? Can you fire up a virtual machine? There you go, you can do that. And I've actually run multiple courses from a virtual machine on my desktop now for 8 months, and it just works. Now, I do have plan B, plan C, plan D, plan E, plan all the way down there, so eventually there'll be effectively precious little downtime, but we don't need the latest and greatest. We don't need incredibly powerful hardware, pardon me. We don't need leading-edge cloud services just to execute these virtual machines. In terms of reliability, it's gone down once in 3 years, and I must admit that was my own configuration mistake there. We do use it for coursework every single day of the year, and we do use it for exams as well. And we've never had any instances of outages as far as CodeRunner or Job Engine are concerned during exams. Worst case, if there was, the students have still got their code on the desktop, and Moodle's got a cache copy of whatever it is that's been uploaded. So there's precious little chance of students actually losing work there. In terms of security, the job execution engine itself is firewalled. So students can send code to the job engine will execute the code, and hopefully there'll be some folks in the room thinking, that's interesting. If I can send a machine some source code to execute, I wonder what else I can do with it. And yeah, sure enough, and that's actually possible. You can send any Python source code to the job engine, and it will execute it. So much so, it's firewalled as to what it can, or how far it can actually go. So it operates inside a virtual machine, which itself is actually sandboxed, so much so that when a block of code is executed, the next student who comes along and says, hey, can you execute my code, receives a new sandbox, and then there's nothing, there's no lingering anomalies there from the previous execution of code. And I said it's firewalled so much so that the students can't go outside that particular virtual machine. We could allow it to go over to, and I'm thinking about this for later, to go over to a local provider or maybe a source of data, and we have lots, just like you folks do, we have lots of sources of open data inside New Zealand where we can connect to that and then download the data in real time. So even though it's firewalled, we can allow this to operate in a controlled manner. In terms of Moodle, pardon me, you can appreciate this is a standard Moodle quiz. And let's just have a look at this. I'll just do it from a demo perspective. If I go to my practice lab, I've actually gone inside my course here. If I go and preview this. So this is literally my very first question, just to get folks into the idea of submitting their code to Moodle to see what it's like. I give them the actual string that they need to have displayed if it's a program that's going to display output, just so there's no typographical mistakes there. And then the students go and write their code, which hopefully looks something like this, which has got an intentional typo mistake inside there. They've developed this on their desktop. They're pretty sure it's correct. They send it to Moodle. They click on check, and Moodle says, oh. It's a bit embarrassing, especially in front of a group of folks who write Python. So Moodle said no at that point, but it said no because there's not enough comments inside the code. So I've actually got Python inside CodeRunner, inside Moodle, which looks at their source code and says, for a program with this complexity, I'm expecting to see so many comments. I'm expecting to see a comment block at the start, which is formatted in a particular way. I'm expecting to see a rough number of source lines of coding there. And I've clearly not met that. So if I go back here, if I add some more comments, then hopefully that particular test will now pass, and I'll submit my code, and this time, still got it wrong. Need to read my own question. Expected, hi and welcome to DTech 501. Got, hi, comma, welcome to DTech 501. Clearly I wasn't reading the question. If I change this to what it should be, hello and welcome to DTech 501, click check. Now Moodle goes green, all within, and I've timed this all within about 200 milliseconds. That includes going from here to our instance of Moodle in Hamilton, takes the code from Moodle in Hamilton, send it down to Christchurch, get executes, goes back to Hamilton, comes all the way back over to Sydney. So students can do this from anywhere in the world and receive feedback on that to say it's passed, in this case just one test, but it's passed these whole sequence of tests, or it's failed at this particular point. So that's just the introduction question there to show students about the actual process of submitting code to Moodle for execution. Now, clearly, it's a very simplistic program. There are other programs that the students have to write, maybe 20, 25 lines of code. Pardon me, a little bit more involved there. In this case, here's an example where they have to write some code to simulate marking and assessment. So we've got some boundary tests here, so we can test whether it's, to gain a distinction, it's inclusive of 90 to 100. It's not just 91 to 100, it's not just 90 to 99. And then all the associated test data then maps onto that to say, have you passed this particular boundary test? And once again, I'll give the students some of those pieces of test data, but most certainly not every single piece of test data. And if we scroll down here, there are some of those example tests that are there, in which case the students are encouraged to go into the input section, grab those pieces of text and then apply them to their own development environment on the desktop. Once again, ensure they've actually got a working program, send it back to Moodle, and then it's marked just as it was, just as you've seen the earlier ones. In terms of the output, Moodle will say, I expected to see this. You saw me make that typographical mistake earlier on. I expected to see this particular piece of text. I received this particular message instead. If it's necessary, there is a show difference option inside Moodle. They can use that. Or the students can take the difference, then put it through a diff tool to see which particular section of code was displaying the actual message. Once again, this is all for programs which display messages. Obviously, functions are quite different than the test data for a function. If it's returning a Boolean, it's going to say, I expected to receive true, but I received false. And I've got lots of test data inside there, which actually does both negative and positive, or forces both negative and positive responses. In terms of what the students think, they like it because they think they're talking to the machine. And when it all goes green at the bottom there, it's almost like, yes, 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 I've actually beaten the machine. This is good. And I'm still at the front of the class thinking, hey, what do you think of that question? Yeah, Dave, it's great. Just let me go on and carry on with the next question. And they're really intensely interacting with this whole concept of getting to write code. So much so that I've actually seen students who've entered my course who, I must admit, entered the course with a little bit of trepidation. They weren't entering the course to be programmers at the end of the day, but the fact that they have gone through this process where they write code, they send it off, and then this machine marks it within a fraction of a second has actually got them to the level where they absolutely love writing code, and that's just superb to see. I asked some students about a year ago how this could be made better, and I remember one of them distinctly said, I did a programming course a couple of semesters ago, and I spent 14 weeks not knowing where I am. Done your course, and in half a second, I know whether one question has given me the right answer or not. Don't change anything, mate. I said, half a second? I'm sure I can make that better. And I did. I knocked it down to 200 milliseconds. But it's this immediate feedback the students absolutely love. Every now and again, they'll email me some code and say, hey, Dave, I'm stuck here. What do you think? And I'll respond to them and say, have a think about this, have a think about this. They do that, and then they're back up and running. But they really, really, really like the concept of they send the code to the machine, and the machine gives them immediate feedback. So, the future. Other languages. I know it's a Python conference, but it's not just Python. Job Engine will execute any code that you send it. You can send it C code, you can send it Node.js, you can even send it SQL. So whatever interpreters or compilers are installed on that virtual machine, the Job Engine will go and execute that machine. It can also analyze data, so it's not just about taking source code and executing it. I'm currently looking at simulation packages where I can take a configuration from a simulation package, run it through a command line version of that, get the answer, and then say to the student whether their simulation was actually designed well or not. I'm looking at analyzing docstrings. So the test code I've currently got just says, do you have a docstring or don't you have a docstring? But the million-dollar question is, how good is that docstring? Does it actually describe that function correctly or accurately? Well, that's most certainly work in progress. Installation instructions. So for those who have Moodle, you need the CodeRunner plugin. The installation's on that particular site. The Job Engine is available from GitHub. It's maintained by Richard, so please download the code there. Now, million-dollar question. Do you have the resources to host a job engine yourselves? And as I said, you don't need the latest and greatest technology. A fairly high-spec PC will run a course for 60 or 70 students without an issue. But the key point here is it actually requires subject knowledge of configuring Linux virtual machines. And some folks just may well not have the time to do that. So my question is, for the teachers who are present in the room, perhaps consider approaching a local service provider and say, would it be possible for you to host a virtual machine for us that does that? See if you can get together, pool your knowledge, and maybe create a shared service. So one of the things I'd like to offer today is, what can we do together in terms of creating a virtual machine which will execute student code? And I'm sure between all of us, we can come up with quite a decent service there. As has been said by previous presenters, what else can we do together in terms of sharing code? So I'm all for creating resources such as pools of questions on particular topics, putting them on secure sites, and then have other folks download and give that feedback as well. So that's one of my key points that I'd like to mention today. Thank you very much for hosting me today. It's really appreciated. Kia ora.
Flashing. Oh, there we go. Okay, I'm on. Thank you, Dave. I've got time for a couple of questions. Is there anyone with a question in the audience? No? Oh, yeah, there's one. I was going to say, otherwise I've got one and I'll steal the spot, but we'll go to the audience first.
Can we have a preview of marking script just to see how it looks like behind the scenes?
Yes, most certainly.
For this high-end welcome.
That was my question. Good one.
Okay. Let's go and have a look at this. Just because it's on that particular screen at the moment, we'll go and have a look at this particular question. This is the one which emulates marking typical assessment with various boundaries there. So this is the code that I've added to this. So I'm looking, this is the code inside CodeRunner, which initially looks at the student submitted code to say, have they used particular variable names? So inside my examples, I've got first name, last name, and grade. And what I don't want students to do is to take those as literals and then use those as variable names straight inside their code, because what I really want is good object naming examples from the students. So I'll scan through their code just looking initially to see if they've copy and pasted my suggested names at that point. And if they have, their code is rejected. I also look for the number of comments and potentially the length of comments. Now, clearly, I'm not analysing what the students are saying inside the comment, but I'm seeing some evidence of comments being inside there. So I'll go through this process, just doing a quick check of their code, and if I found any issues, I'll give them some feedback to say, please address these points. Otherwise, at that point, their code is packaged with the test data and then sent off for execution, and then it comes back. If you're interested in any of this code that I've got there, I'll quite happily send it to you. Thank you.
Okay, any last questions? No? Great. Okay, well, thank you, Dave, for sharing that and the work that you're doing. I think it's always good to see ways that we can automate some of what we have to do in class. So
that's grand.
Gift for the conference, and thank you, everyone, for coming in and hearing what Dave has to say. Now we have a change.